Yo, Zantino, you're the first one to notice. Kind of fits, doesn't it? Thought that was a nice little Easter egg. Okay, where are we at there? All right, y'all should be able to hear me pretty good. What are we doing today? We're doing stuff. Zantino, how are you? So if you guys missed anything the last few streams, we've built things. Let me go grab the little robot real quick. We've built the singing Tesla coil, the robot Gilly Man, and pushy button light thingy that glows when you push the button with a USB-C connector. So some cool stuff. What are we building today? We are building something. It is a thing. Probably not going to do the Game Boy today. It's going to be tomorrow. I don't know what time is it. Yeah, it's already 8:30, so that'll be tomorrow's stream. I may build a GameCube so I can stream Star Trek from here. That sounds terrible, but anyway, we are building a signal generator. You guys hear me okay? Hey, we have English instructions. That's nice. Okay. So this is the function generator. Okay. So let's take a look-see here at all of the important parts, right? Function generator component layout diagram. Triangle sign. These are different waveforms, okay? It's funny, this is literally just a print off of this. JK1, just kidding, that's probably the power. We go here, JK1, DC power, by screen printing layer. Okay. So let's see here. R1 resistor. R2 adjustable resistance. Doesn't really tell us what that does. Okay, so how's everybody doing tonight? Hopefully you guys are doing all right. So, resistor, regardless of the polarity. Bi-screen printing layer. These are the parameters. What it's talking about here is basically the polarity, the orientation of the stuff that you're supposed to install. Regardless of the polarity means it doesn't matter which way it goes in. Okay. The positive long feet. It almost feels like we are in the backstroke of the West, the third gathers. The positive long feet. It's kind of nice that they have these here, though. Let's read the instructions. The welding installation considerations. Follow these steps. Components are welding the front board from low to high principles, namely the first low welding components such as capacitor, resistor, diode, etc. Welding IC socket, terminal blocks, finally power socket, adjustable potentiometer. The back with the diagonal cutting pliers to cut short the pins as far as possible. We've definitely read worse English before. Debugging steps. Okay. After completion of welding on IC XR2206, pay attention to the direction of IC. Insert the might damage the chip! Exclamation point. That's very, gotta put the emphasis there. Check the IC weather against, such as anti-please timely correction. Okay, insert the power supply for 5.5 times 2.1 port, center positive, barrel negative for 9 to 12 volt power supply voltage. Supply more than 12 volt, the output waveform is unstable. Okay, using the step J1 jumper cab plug in, side tri blue terminals, output sine wave, note J1, J2 can only insert one of. J2 jumper cap plug in, side tri blue terminals, output triangular wave, note J1, J2 can only insert one of. It's very confusing. Does anybody know what that means? Screw, blue terminals, output pulse, amp, sine wave, triangular wave, amplitude adjustment. Fine, frequency, fine adjustment, coarse, frequency of coarse adjustment. Schematic diagram of function generator. So this is basically just just one of those chips that is a function generator and has all the components built into it. It's not really doing anything crazy. So let's kind of zoom in here and we'll talk a little bit about the schematic. So R7 and R8 are going to be your fine and coarse frequency adjustments. As you can see, one's a 50K, one's a 100K, and they're in series here, so that's going to adjust that. Hopefully you guys are following along. Maybe you don't care. You might not care. 5.1K, just in case you short out these two, you have some resistance there to TR1. TR2 is not terminated. We'd have to look up this chip to see what all of these do here. Okay, so R2, we've got a voltage divider here. So that takes your VCC, divides it in half. So if we're going with 9 volts, I get 4.5 volts. And that turns that into another voltage divider, which that's going to adjust the amplitude here, which is going to be the MO. That's pretty much it. This is very interesting here. It doesn't say that J2 does anything. J2 is storage. I bet it goes to, when you put it on J2, it goes to triangular wave. It's on J1. So when these guys are, when 13 and 14 are tied together with the jumper, you get the thing. And when you remove it, you put it on J2. It opens the circuit, and then it goes to the triangle wave output. And apparently it has a separate square wave output. Yep, so that's P1. Yep. So that's your square wave. The STO goes to pin 1. That's interesting. It says pin 1 is, oh. Those are not, those don't correspond to the board. Okay. Anyway, how's everybody doing? How's your Tuesday? Hopefully you're doing well. Let's start welding, everybody. we even have anybody? Am I talking to myself? I talk to myself a lot, so that wouldn't be the first time. And I forgot to bring my oscilloscope. So, we're going to have to do this with the old-fashioned oscilloscope. No one likes welding indeed. Snick, hello. Snick 500 and Erdog. Okay, as per these other projects, we're going to go ahead and put some of the more mechanical stuff, like these knobs. We're going to put them up. We don't need knobs. We don't need screws. We don't need these tabs. Oh, these are our jumpers. We'll dig them out. This is stuff for the case. Snick, how are you doing? Have you recovered from the bullshittery of last night? Okay. So let's do some resistors first. We'll do all the resistors. Why am I fighting with this? I have a tool that will help me. Okay. It doesn't tell me the values of things. Okay. So that's going to be fun. So we will go back to the schematic. Hey, Frank, we are building a waveform generator, or a function generator, if you will. This outputs a sine wave, a triangle wave, or a sine wave, and you can vary the amplitude and the frequency of it. So, let's see, R1 is a 1K. R4 is a 330. Why do I have so many resistors? Oh, they didn't. No, R4, R1, what is R6? Oh, R3, R5, R6, or 5.1K. Okay. So we should only have 5 resistors. So, let's go with R1 first, which is a 1K. So that's going to be a brown, black, brown? And I was going to start earlier, but I was working on the truck and I had to make a run to the old hazard fraught. So let's see if this is what we're looking for here. Like I said, it's going to be a brown, which is 1, black, 0, 0, and then another brown, which means the multiplier. So that's a multiplier of basically 10. So 100 times 10 is 1,000, so it's a 1K resistor. But yeah, we're kind of building some stuff. Yeah, we're already zoomed in, so let's go. 978 kilo ohms. So that looks like an R1 to me. Let's go ahead and put in R1. So Luthon, do you think we're actually going to get Wazdaka? We think 11th edition is going to be better than 10th. This is R1. We're going to go ahead and put it where R1 says. We're going to put it in regardless of the polarity. But Frank, tomorrow will be a modding stream, hopefully. I'm probably going to do another GameCube. So I can have one here at the shop. And then this guy. We're expecting to see an orange, black. See an orange, black. So that's the one we want. And that is going to be our R4. Let's test the... Okay, 330, 324, close enough. Okay. And we have our next ones, which are supposed to be 5.1K. So 5 is green, 1 is brown. So let's take a look at these guys and see what they are. Well, it'd probably help if I got them in frame, huh? Okay, so green, brown, black, brown. And then the last brown is the tolerance. Okay, 5.05, close enough. I keep hoping. I think it's going to be an awesome starter set. What do you think they're going to do for the Space Marine side? There's obviously some talk about the land speeder. Okay, so R6, R3, R5, and R6. Okay, so R3. Yeah, but I wonder what that means as far as tactical Primaris. Does that mean that it's just like a Primaris squad that's set up like a tactical squad with options? You think we might actually get options again? Okay, let's go ahead and do our welding. That'd be phenomenal. I don't think it will be. I don't think that'll happen. But you never know. So, Snick, how did the rest of your adventure go last night? All right, cool. Well, we've got the resistors mounted. Oh, and that one's kind of fucky. Well, let's go ahead and fix that real quick. That's going to bug me. Damn it. Close enough for government work. It's supposed to be an Adepticon. Okay, so what do we want to do next? Probably do the capacitors. What are the capacitors here? Non-polar capacitors 104, 105. 473, 222, 101. Okay, so all the capacitors are different. So let's do C2 first, which is 104. Okay, so we're looking for C2, is 104. Okay, so it's kind of hard to see, but it's going to be this guy right here. So, put 104 in. That's C2. Yo, Arctic! They are delicious indeed. How are you doing, my friend? Okay, so the next one we're going to need is going to be C5, which is a 105. So C5. C6 is a 473. Are we missing a capacitor here? Uh-oh. It ended up in this baggie. This is not ideal. Let me read this again. C2, so that's 1, 2, 3, 4, 5. 1, 2, 3, 4. Well, fellas, I think we're missing a capacitor. I was about to say, I haven't seen you around here much lately, dude. By around here, I mean on Twitch. It sounds like you've been at it pretty solid. I'm sorry, that sucks, man. I can say I feel your pain, but Luthon, I will ban you. And I won't even feel bad about it. Okay, so we're missing a capacitor. Luckily, I have some. Okay, so a friend of the stream, Chris, who I've done some mods for here, has just sent me some text messages on some really cool stuff he picked up. We have some, I've got some stuff I'm going to be doing for him on the stream coming up. Yeah, I missed your streams, man. I never got to catch them because you always start streaming after I went to bed, which is crazy because I usually stay up kind of late, but I get it, yeah. Well, I hope things level out for you, dude. I mean, you know, having lots of work is good, but it's also bad. Especially when you're, you know, trying to raise a family. That's rough. Okay, let me grab my components. All right, we got ourselves a box of cheap Chinesium capacitors here. We are missing I believe 473. That's going to be a one of these guys right here. There's 473 printed on it. Whether it is or not, you know, that's anyone's guess, but. Okay, so that's going to be C6. It's going to be kind of funny because this is. Different capacitor. C7 is 222. And C8 is a 101. When's your, you got a video you working on or anything you can talk about in that regard, Arctic? Okay. Let's do the soldering now. Okay, time to do some trimming. Okay. So the next part, electrolytics. Okay. So C1 is 100 microfarad. Oh God. Okay, there we go. That is a terrible way to indicate polarity. I hate that. I don't think that's it. Okay, excuse me. VCC is pin 3 of jack 1. Also goes to R3. C2. That's pin 1, so that should be ground. And R8 has a pin connected to ground. I'm going to go with that is Yep. So, okay, center pin of the jack is ground. Okay, cool. All right, so okay, what's next? Oh, C3 and C4 are the same. I wonder if that needs to be tightened a little bit. It feels kind of loose, but we'll work with it. Okay. So how's everybody's, what is this, Tuesday? It's Tuesday. Get on there. Okay, now we got the capacitors. Let's go ahead and do the jumper. This is going to be kind of a pain in the ass. The way I like to do these is I like to hold them in place with one finger and then tack one of the terminals that I'm not actually holding with the other. No, we could do it like this. I've never actually tried this. This seems okay. See if this works. Might have had a bit of a brainwave here. Yeah, that actually worked pretty good. I've never tried that before. You ever done that before, Chip Gal? Held the solder with a third hand. I'm gonna heat my iron up just a little bit more. Mostly because I'm impatient. You were the third. Unfortunately, it's just me here at the shop. I could have used a hand earlier today. I wish Merker would have been here. I got the hole drilled in the firewall for pulling the power in the car, in the truck. So I've got some nice thick 8-gauge cable I'm going to use to run radios and inverter. And I went to install the grommet, and I realized there's no way in hell I can reach in through the top of the hood and then under the driver's side foot compartment. Oh, it's not that big of a deal. I'll just have someone help me at work tomorrow. It was much more frustrating figuring out how to get a drill. $30 at Harbor Freight later. I bought one of those like flexible drill extensions and a long drill and then some impact drill bits, and that fixed it up fast, quick, and in a hurry. Okay, this one's gonna be fun. I'm probably gonna burn the shit out of myself when I do it, so. Or, oh my god, it actually stays in place. Does it? It does. There's another way you can do. You can also do this with painter's tape or Kapton tape. I'm trying to be lazy here. So, by the way, new video up on YouTube. If you guys want to check it out, of the musical Tesla coil. Okay. I had to. Chip Gal, you'll notice one of the capacitors here is not like the others. There was one missing from the kit. Luckily, I bought myself a kit of caps a while back, and I happen to have one in there. So what's next? Let's do the IC socket. Okay, so one of the things you'll notice on these guys here so you'll notice the socket itself has this little notch in it. Little notch there. Sometimes you got too much zoom. Okay, you'll notice that the socket has a little notch right there, not one on this side. Oh, I know, but I bought them so I didn't have to ransack the drawers. And you'll also notice that the chip has a notch as well. And this is really useful for retro stuff as well. And finally, our PCB has a notch. And that's the orientation. That's how you orientate it. Uh-oh. Looks like one of these guys bent. Yeah, that's what I was afraid of. Two of them bent. Yeah, let's try that again. Okay, there we go. We got all the pins, so. Okay. Put this guy in. I'm really not terribly happy with that solder joint there. It looks like we lost our music. I ran out of music. Okay, there we go. I'm happy with that. Let me get some Muzaks going again. Oh, why not? Okay, so these actually matter here. So R2 is B503. It said B503, B104, B503. Okay. So R1, R2 is a B503. R7 is a B503. R8 is a 104. Ultros do not. Ultros Gambini, do not come into this sanctuary and post your trash. Your blasphemy is not welcome here. And I can't believe everybody in chat. You're not, don't come. Do not come. Crank this up another 5 degrees for this part. Ultros, how are things up in America's hat tonight? How is Oliver? Have you pet that kitty in the last 5 minutes? And if you have not, why have you not? We got one last part, the DC jack. Use my patented third hand solder helper method here. We're just tacking that in place. We'll go back and put a better joint on it when we're done. Ultros, cease your bullshittery. We're on to you. We know the lies you speak. Those who are in the know here know the X is not to be trusted. And those that speak kindly of the X are also not to be trusted. Hello, the X did descend upon the void, marked as a sign of crossing paths, divine decree. Its form was power, in its presence was judgment. It rose against Aramis Belmont, casting down shadow with radiant might. Chat beheld it, knew deliverance was at hand. X stood unbroken before the dark forces, its strength unwavering, its purpose eternal, and through it, salvation was promised to those who believed. The only salvation is damnation. He should be merping his way into your room soon. That is what I like to hear. Okay, we got one more thing here. We got to install a Yaled Chippy. Look at that absolute unit. That meow box is quite an acceptable meow box. Okay, we have inserted the chip. I have no idea what this jumper header is for. Okay, so we're going to start off with a sine wave. Okay, luckily we don't have to trim anything else. Okay, now we can put these on here. They fit a little tightly for my tastes, but it'll be okay. Okay. I was hoping to have my oscilloscope kit, but that will be here soon, so. In the meantime, let's give it some power, and let me see if I can turn on my oscilloscope. Didn't mean to do that. I don't switch for this thing. I always kind of pain in the rear to get to. I probably need a probe of some kind. Or I got a probe somewhere, do I not? Probe. Okay, so let me see if I should be able to get this to work. Oh, I could always mount another camera. Do much for us, does it? Okay, cool. So let's play with our oscilloscope here. Okay. Okay. I want to do channel 1 there. not giving me an output here. Here's my probe bed. We just not getting an output. Huh. Okay. Well, I wonder if this probe is bad. That's possible. We are testing, Snick. Something real quick. Okay. There we go. Okay. So, right now we are looking at, that's the offset. There we go. Boy, that needs some cleaning, doesn't it? Okay, so what we're looking at is a sine wave here. Coming from, and you can't really see. Can I zoom out anymore? Nope, that's it. So over here, I've got a function generator. So we're looking at a 1 kilohertz sine wave that's roughly according to this should be 5 volts peak to peak. So 1, 2, 3, 1, 2, 3, 4. Calibrate that right there. So that should be 5 volts peak to peak. There. So we can increase this to, if we increase it to 2 kilohertz, we'll notice that it gets closer. And let's go ahead and go 10 to the 2. Okay, so this is 100 hertz, 200 hertz, 300 hertz, 400 hertz, 500 hertz, 6. Okay, so we see the oscilloscope is doing what it's supposed to do. So let's go back. Let's go kind of calibrate for a 1 kilohertz sine wave. 10 to the power 3. See, it's not a perfect sine wave, but it's close enough. That should give us a good look there. So how did the AIM 54 shooting go? Okay, so what we're going to do is we're going to hook this up to power. In fact, I really want another camera, don't I? How can I go about doing that? Screw it. We'll just swap back and forth. You guys know what this board looks like. So let's go here. So, the boomsticks, how are you doing? Okay, so I need to test my probe real quick. See if this probe works, because it looks like that was the problem last time. Okay, so this is 20 megahertz times 10 times 1. We wanted a times 1 mode. Plug it in. I should be able to just plug this little bastard in right here. There we go. Okay, so I think that probe is bad that I've got. Okay, so this one works. So let me do this here. Will it let me save? Yeah, it's not gonna let me save that, so we'll just do this here. Okay, and then I'll just move it back manually whenever it's time. Okay, so we need to give this power. Needs I believe 9 to 12 volts is what it was looking for. Okay, give it power there, and then what we'll do is that's the easiest way to go about this. That would probably be the easiest way, but let's do it like this. We'll just use one of these. Damn it, get in there. And then let's do... You know what? Are you... Yeah, let's just do you here. So, let's do this first. Then we can just move it over. Okay, so we're going to look at the sine wave output of this first. I'm going to turn this power supply on. At about 9 volts. Okay, nothing's on fire yet. We're going to clip our oscilloscope here. And here. Okay. Oh, okay. So the amplitude is backwards. Happens when we get a little closer to 12 volts. So honestly, it's not really a great sine wave, to be honest. Right? Oh, well, you guys can't see any of that, can you? Okay. So, a 12-volt power supply. Still not. We get a pretty high offset. We go here. Now you could do some filtering and make this better, but sine waves are kind of hard to. If we get kind of closer to the middle of the range there, it looks better, but as we get kind of there, not so great. So let's look at the triangle wave now. That's funny, whenever I remove that, that actually looks quite a bit better. See if we can get triangle wave. It's not a triangle wave at all. Okay, well, now let's look at the square wave, shall we? I don't know about y'all, but that doesn't look like a square wave to me at all. Does that need to be on sine? Well, doesn't tell me what that is for. That is most definitely not a square wave, though. Kind of. I mean, it would work as a trigger. But I'll show y'all an actual square wave here. The boomsticks, it's just a kit to build. So, you know what? Let's go into channel 2. If I go over and switch to channel 2. Channel 1, channel 2. There we go. Forgot you have to do that. So this is what a square wave looks like on an old school oscilloscope. Oh, keep forgetting. I gotta. So that's kind of what we're supposed to be looking at there. And I mean, it's got a nice fall off, but definitely not ideal. But this thing was also like $5. I am disappointed between the lack of the triangle wave. That's not very ideal at all. I'd have to look into that chip. There's probably some filtering stuff missing from it in this more simple circuit. But you could certainly use that for whatever you needed. Square waveform for the most part. But like your rise time is not ideal there. And I mean, part of that is I just have kind of a jumper wire there, but that shouldn't really matter that much. But why would I need a bigger boat? That is the real question. Anyway, so it's a cool little kit to build, play around with. And I'd say like 3 out of 10 as far as the performance goes, because that kind of sucks. Because we really wanted. There's your different triangle waves. PWM square wave, inverted. Sawtooth wave versus triangle. Or sorry, that's triangle. That's sawtooth. And there's your sine wave. And that's not perfect, but this is also like a 40-year-old piece, probably older than that. I don't remember exactly how old these are, but as you get lower in frequency, it performs quite a bit better. So anyway, if you guys are interested in this part of it, I could talk about all this shit for days and days and days on what these different things go. This is a pretty cool setup. I've got a universal counter over here. I don't know if you can see that from. Let me see if I can. Can I get that in the shot? I wonder if I do it like this. It's gonna be sideways, but yeah, so we've got a counter over here. In fact, it should be a 1 kilohertz sine wave, so if I plug this in here, it says 1 kilohertz. If we go, it'd be 10 kilohertz. Not going to be exact. Kilohertz. $100 kilohertz. And that's as high as this will go. But we should be able to crank it all the way up here. Let's see if we can get to a megahertz with this thing. So you're gonna let us. Almost a megahertz, 950 kilohertz, a 0.9 megahertz. I love these vernier dials. There's something. If we can get down to 1 hertz. Anyway, kind of cool to play around with. So yeah. It's kind of cool to build that. I am disappointed in the I mean, for the price it's not bad. A decent actual function generator will run you tens of thousands of dollars, so I didn't pay that for this one here. I paid $200 or $300 for the setup up there. Anyway, I think I may actually call it here. I'm kind of tired. I was going to do some more, but got that done. I don't see Wyvern, so we're probably not going to open Pokemon's cards. I guess we'll get finished building this thing. Oops. Oh! I wonder if that was the problem. Let me put this thing together. The way it's supposed to be. I can get these damn things off. Damn. I glued these fucking things on. fly off to? Here somewhere. It's not a minute. Oh, well, don't tighten those too much, apparently, boys and girls. Gotta be pretty gentle with that, too. Hey, do I have any more of those wires over here? That would be super handy if I did. Stop that. If I just hit, well, I'll just put that back in. Did I already lose it? Oh, there it is. It may have been taking issue with the fact that this jumper wasn't hooked in, so. Okay, and let's go back up here. Okay, so what's happening? Well, we have it at basically 1 to 10 hertz. And this is kind of what a sine wave does. Okay, so let's kick that up. To the next frequency band. Yeah, that actually looks quite a bit better. So we'll notice there, so if we increase the power supply, about 12 volts. See, we're hitting the rails of the power supply there. So if we go here, you can see us hitting the rails of the power supply. That's causing that clipping there. Okay, that's actually a serviceable. I wonder what it looks like when we... Oh, well, if you actually do it right, look at that. Look at that. That actually looks... Okay, that's a passable sine wave, and that's a passable triangle wave. I'll have to look at the square wave. Let's crank it up in frequency some. Okay. Okay. What kind of plan are we thinking about, Luthon? So it's just a tool, basically. So I mean, I could hook this up to the Tesla coil, but I don't have an extra power supply. Yeah, I'd have to mess around with that to get that to work with the Tesla coil, but do you guys want me to build a bigger Tesla coil? Like I kind of want to. I can turn the soldering iron off for now. Well, I'm sure you'd kick an ass or two, Luthon. So this should go all the way up to 1 megahertz. And there's our 1 megahertz. Let's see if so if I plug this in here, maybe that'll give me. Oh, there we go. We'll get this all the way up to 1 megahertz. All right, there we go. Okay. Oh, anyway. Oh, you guys couldn't even see that because I didn't have the counter up, but... yeah. Anyway. I think I'm probably going to call it. Let's go find somebody to raid. I will be back tomorrow. We'll be doing... I don't think my AliExpress stuff is going to get here in time. So, probably won't be doing any more building. But... we will, build a Game Boy tomorrow. Who are we raiding? I'm pretty sure I know who. Anyway, thanks for hanging out, everybody. We'll see you next time.
That is the first time in all of the loops I have ever one-shot that boss. Holy crud, I think I figured out the patterns. Yo!